Welcome to GATE Metallurgy Solution. This is question number 17 from GATE 2021. Melting point of copper is 1358 Kelvin and its enthalpy of melting is 13,400 joule per mole. So, the value of free energy change for a liquid to solid transformation at 1058 Kelvin is, assuming Cp of liquid equals to Cp of solid. So for this question, you can also refer NPTEL reference Module 1 Lecture 16 of Advanced Metallurgical Thermodynamics course by Professor B.S. Murthy from IIT Madras. So before solving this, let us first understand some basics of free energy change for a solid to liquid transformation. So free energy change at a temperature T is given as delta G equals to delta H minus T delta S. So you can take it as a equation 1. So if you talk about transformation like a solid to liquid or liquid to solid, so at melting point or at equilibrium temperature, equilibrium melting temperature, the value of delta G will be equal to 0 because the free energy of liquid and solid are equal at a melting point. So this will be equal to 0 at T is equal to Tm. Tm is nothing but our melting point. So if you try to put the value of delta G in the equation 1, you will get free energy change which will be equal to 0 equals to delta H minus T delta S. So if you solve, we will get delta Sm equals to delta Hm upon Tm. So delta Sm is nothing but entropy change at melting point, delta Hm is enthalpy of melting, and Tm is the melting temperature. So this you can assume it like equation 2. Now in the question it is given that Cp of liquid is equals to Cp of solid, which means if you take the value of delta Cp for this transformation, it will be equals to 0 because both are equal. Now there is an approximation which is given by Turnbull, and that approximation is nothing but if you solve this equation 1 and equation 2, you will get delta G equals to delta Hm times delta T upon melting point. So this relation is known as Turnbull's approximation, and for this relation this assumption is made. Now coming to the problem, let us see what are the datas we have been given. So we have been given this melting point of copper equals to 1358 Kelvin, and we are cooling it below melting point. So the delta T value will be 1358 minus the transformation temperature which is given as 1058 Kelvin. So if you subtract this, you will get delta T value which will be equal to 300 Kelvin, and the value of enthalpy of melting. So we have been given enthalpy of melting, which means it is enthalpy of solid to liquid transformation, but here in the problem it is asked about liquid to solid transformation. So we have to just take it with the negative sign. So delta Hm for liquid to solid transformation will be equals to minus of 13,400 joule per mole. Now to calculate the delta G value, simply put all these values, which is nothing but minus 13,400 times delta T, that is 300 upon melting point, which is 1358. So if you solve this, you will get minus 2960.23 joule per mole. So this will be the right answer for this problem. Thank you.